Hello students, in this video we are going to see how a non-homogeneous linear differential equation of higher order with constant coefficients can be solved. In my previous video, I have explained how to find the solution of a homogeneous linear differential equation of higher order with constant coefficients. This is a homogeneous linear differential equation. Homogeneous means this side will have 0. Now we are talking about non-homogeneous linear differential equation. So left side there is no change, but right side instead of 0 will have a function of x. Let that function be q of x. So q of x, this can be rewritten as, already in my previous video I have explained all these parts, but again I am repeating, a naught dn power y by dx power n plus a1 n minus 1th derivative of y with respect to x plus etc. up to an into y equal to q of x. In all the terms I can take y outside and I am going to use the symbol capital D is equal to d by dx. So I am getting the equation a naught d power n plus a1 d power n minus 1 plus etc. up to an into y equal to q of x. This is a function of d. So I can write that as f of d, function of d into y equal to q of x. This is a non-homogeneous linear differential equation. Now come to the solution. General solution of the given linear non-homogeneous linear differential equation y is equal to CF plus PI. CF is the complementary function plus PI means it is the particular integral. Complementary function, for finding the complementary function you can go through my previous video. In that I have explained all the things. Complementary function in that video is nothing but the final solution. So kindly go through that video. Again I'll repeat the same in this video also, but if you want clarity kindly go through that. And particular integral, for finding the particular integral we have totally 5 cases. Depending upon the right side function q of x, we have to find the particular integral. So first one is q of x is equal to e power ax plus b. The second one, q of x is equal to sin ax plus b or cos ax plus b. The third one is x power m, or it's a polynomial of x. And the fourth one is a product of e power ax into function of x. And the last one is x into a function of x. In this video, this is part 1 video. In this video, I am going to explain how to find the particular integral of the given q of x is of the form e power ax plus b. This is the first problem. We are going to find the solution. We are going to solve d square plus 5d plus 6 into y equal to e power x. The general solution y is equal to CF plus PI. How to find CF first? Already in my previous video I have explained how to find CF. Anyway, we are going to do now. If we take the given equation as equal to 0, what's the first thing we have to do? We have to write the auxiliary equation first, right? What's the auxiliary equation? We have to replace d by m. So m square plus 5m plus 6 equal to 0. And for this equation we have to find the roots. How to find the roots? Multiplying these two, we are getting 1 into 6 equal to 6. That is, product is 6 and the sum is 5. For 6, the factors are 1, 6, minus 1, minus 6, then 2, 3, minus 2, minus 3. That's all, no? And which will give the addition 5? This will give the addition 5, right? Change the sign and give as the roots. So minus 2 and minus 3 are the roots of the auxiliary equation. So m takes the value minus 2, minus 3. Both the roots are distinct. Then how to find, how to write the CF? Usually in my previous video what I said is that is the final solution, since in that only right side value is 0. But here the right side has the function e power x. So don't write as the final solution. We have to mention that as complementary function. So complementary function is equal to, what's the format we saw there? C1 e power the first root minus 2 into x plus c2 e power the second root into x, since both the roots are distinct. So this is my CF. Next we are going to calculate the particular integral. For calculating the particular integral, we have to take the inverse 1 by the given f of z, that is this term d squared plus 5d plus 6, that you have to take in the denominator, d squared plus 5d plus 6 into q of x. What is our q of x? The right side value, that is e power ax. Okay. And this is the procedure for finding the particular integral if q of x is e power ax. In the denominator, we have to replace d by the coefficient of x. So here the coefficient of x is 1. So a is equal to 1. So we have to replace d by 1. So replacing d by 1. So 1 by 1 squared plus 5 into 1 is 5 plus 6 into e power x, which is equal to 1 plus 5 plus 6, which is 1 by 12 e power x. This is my particular integral. Now come to the final solution, general solution. Y is equal to CF plus PI. CF we got as C1 e power minus 2x plus C2 e power minus 3x plus particular integral pi is 1 by 12 e power x. Instead of c1 and c2, you can use constants capital A, capital B. Is it clear? The next problem what we have is, we are going to solve 3d squared plus d minus 14 into y equal to 13 e power 2x. So what's the first step we have to do? First we have to write the auxiliary equation. Auxiliary equation means replacing d by m. So 3m squared plus m minus 14 equal to 0. For this we have to find the roots. First we have to multiply these two. 14 into 3, which is equal to 42. So factorize this. First we have to find the roots, right? For that I have taken the coefficient of m squared into the constant term with the sign. So it is minus 42. Minus 42, I have listed the factors for minus 42. 1 minus 42, minus 1, this is minus 1 plus 42, 2 minus 21, minus 2 plus 21, 3 minus 14, and minus 3 plus 14, 6 minus 7, minus 6 plus 7. What's the coefficient of m? It is plus 1. Out of all the factors, which will give the addition 1? This will give the addition 1. Am I right? Pick it out. Minus 6 plus 7. We have to change the sign. So it is plus 6 minus 7. After changing the sign, divide both by the coefficient of m squared. So when we divide it by 3, we are getting the answer 2 comma minus 7 by 3. These are the roots of the auxiliary equation. This is a shortcut method. Directly we can go with the expansion and we can find, or we can use the formula method, minus b plus or minus root of b squared minus 4ac by 2a. But this is a shortcut method. It is applicable only when we are able to factorize, and in some, if we add a pair, if you are able to get this coefficient of m, no, at that case we can use this method, shortcut method. Otherwise we have to expand and we can factorize, or we have to use this formula method. Is it clear? Now these two are the roots, these two are different roots. Therefore complementary function is equal to first constant e power first root into x plus second constant e power second root into x. This is our complementary function. Now come to the particular integral. Particular integral is nothing but 1 by 3d squared plus d minus 14 into 13 e power 2x. 13 is constant, so I can take it out. After taking 13, the coefficient of x is 2. So d has to be replaced by 2. So 1 by 3 into 2 squared plus 2 minus 14 into e power 2x, which is equal to 1 by 12 plus 2 minus 14 e power 2x, that is 1 by 14 minus 14, that is 1 by 0 e power 2x. Anything by 0, it is infinity, right? So we are not able to proceed in this way. In these kind of cases, no, we have to do an extra step. I'll explain you how to do it. So from the beginning, we have to start 13 1 by 3 d squared plus d minus 14 e power 2x, which is equal to differentiate this with respect to d. So 3 into 2d plus 1 minus differentiating 14 will give 0 e power 2x. When you are differentiating one time, we have to multiply it by x. I repeat, since we are getting the denominator 0 when we replace d by 2, again we are going to start from the beginning. The denominator term we have to differentiate once with respect to d. So 3 into 2d plus when we differentiate d we get 1 minus when we differentiate a constant term we'll get 0. So 3 2s are 6. At that time when you differentiate one time, we had to multiply it by x. So 13 into x, 1 by 3 2s are 6, 6d plus 1 e power 2x. Again we are going to replace d by 2. So 13x, 1 by 6 into 2 plus 1 e power 2x. So 13x, 1 by 12 plus 1, 13 e power 2x. 13 and 13 will get cancelled. So x into e power, this is x into e power 2x. This is my particular integral. Now the final solution, y is equal to CF plus PI. CF is C1 e power 2x plus C2 e power minus 7 by 3x plus particular integral is x e power 2x. This is my solution. Is it clear? The third problem what we have is we are going to solve d squared minus 3d plus 2 into y e power 3x. This is similar to problem number 1. What's the first step? We have to write the auxiliary equation. Replacing d by m, we are getting m squared minus 3m plus 2 equal to 0. On multiplying the coefficient of m squared and the constant term with the sign, both are positive. So 1 into 2, that is 2. For 2, the factors are 1 plus 2 minus 1 minus 2. Plus 1 into plus 2, the product is 2. Minus 1 into minus 2, the product is plus 2. Out of these two factors, which will give minus 3, the sum minus 3, this will give, when we add minus 1 minus 3, we are getting the sum minus 3. So take this out, pick it out with, you have to change the sign. So since both are in minus sign, if we change the sign is plus 1 plus 2. What is the next thing I said? Plus 1 plus 2 has to be divided by the coefficient of m squared. Here the coefficient of m squared is 1. So 1 by 1, 2 by 1. So 1 comma 2. This is a shortcut method for finding the roots if you are able to get the factors and we can combine. We can compare this with the coefficient of m. If you are not able to factorize in this way, if you are not able to get this coefficient, means we have to either factorize or you have to use the formula method. Okay, since both the roots are different, how to write the CF? CF is equal to the first constant C1 into e power first root 1 into x plus C2 e power the second root into x. And how to find the particular integral? 1 by d squared minus 3d plus 2 into e power 3x. D has to be replaced by 3. So 1 by 3 squared minus 3 into 3 plus 2. These two will get cancelled. So 1 by 2 e power 3x. And finally the solution is CF plus PI. CF is this, PI is this one. Adding these two will give the general solution. Is it clear? The next problem what we have is we are going to solve d square plus 6d plus 9 into y equal to 5x minus log 2. This side it is not of the form e power ax, but we are going to convert this to that format. Okay, first we'll find the auxiliary equation. Auxiliary equation means d has to be replaced by m, so m square plus 6m plus 9 equal to 0. The coefficient of m is 1 and the constant term is 9. It is plus 9 plus 1, so on multiplying these two it is 9, and 1 9 minus 1 minus 9 3 3 minus 3 minus 3 are the factors for this. And here we have 6. Which pair will give the addition 6? This will give the addition 6, taking that with the change of sign. So plus 3, when we change the sign it is minus 3 minus 3, and the coefficient here is 1, so minus 3 by 1 minus 3 by 1, so the roots are minus 3 comma minus 3. These two are the same roots. How to write the CF? If both the roots are same, we have to combine two constants together, c1 plus c2 into x into e power that root minus 3 into x. This is our complementary function. Now come to the pi. 1 by d squared plus 6d plus 9 5 power x minus log 2. This I can rewrite as 1 by d squared plus 6d plus 9 5 power x. I can rewrite in this way, e power log of 5 power x. Since e and log are inverse to each other, both will get cancelled and will get 5 power x. So just for our convenience, since we have a procedure for finding particular integral if q of x is of the form e power ax, we are converting the given problem to that format. So 5 power x we are rewriting as e power log of 5 power x minus log 2 can be written as log 2 into e power 0x. Anything power 0 is 1, right? So this is 1 into log 2, that is log 2, which is equal to 1 by d squared plus 6d plus 9 in log. If we have anything in the power, I can bring it here, e power x into log 5. This x I can take to the front of log, so x into log 5 minus log 2 e power 0x. I can split in this way, 1 by d square plus 6d plus 9 e power log 5. I have taken this as the coefficient of x, so log 5 into x I have rewritten in that way because we have a format e power ax. The coefficient of x is a, here a is 5, minus, since log 2 is a constant, I have taken that to the front. In the previous problem we have taken a constant 3, no, like that I have taken log 2, 1 by d squared plus 6d plus 9 e power 0x. Here we have to replace d by log 5, and in the second case we have to replace d by 0. So 1 by log 5 the whole square plus 6 into log 5 plus 9 e power log 5 into x minus log 2 1 by 0 square plus 6 into 0 is 0 plus 9 e power 0x, which is equal to 1 by log 5 the whole square plus 6 log 5 plus 9 e power log of 5 into x. Actually we have written 5 power x in this way, so I am write it back what I had no in the problem. I have written in that way, 5 power x minus log 2 1 by 9 0 0, so 1 by 9 e power 0x is 1, so log 2 into 1 by 9. This is my particular integral. So the final general solution y is equal to adding CF and PI. The next problem what we have is we have to solve d cube minus d squared plus 4d minus 4 into y equal to e power x. The auxiliary equation is replacing d by m. Now we have to factorize this. We have to find the roots. Since it is of power 3, we have to find 3 roots, right? So I have taken the coefficients in order. The coefficient of m cube is plus 1, m squared is minus 1, m is plus 4, and the constant term is minus 4. We have to start from 1 minus 1, 2 minus 2. So I have taken 1 here. Here we have to start with 0, 1 plus 0 will give 1. 1 into 1 it is plus 1. Minus 1 plus 1 it is 0. 1 into 1, sorry, 1 into 0 it is 0. 4 plus 0 it is 4. 1 into 4 it is 4. Minus 4 plus 4 is 0. If you get 0 as the remainder, we can take this as a root. So 1 is a root. Then we have reduced, no, now we can write this as a quadratic equation. Taking the coefficients in order, this is m squared coefficient, m coefficient, and this is constant term. So m squared, since it is 0, no m term, and it is plus 4 equal to 0. M squared plus 4 equal to 0. Already we got one root. This one we have to find two roots, right? From this one we have to find two roots. M squared plus 4 equal to 0. So m squared is equal to minus 4, which is equal to minus 1 into 4. Minus 1 is I squared. 4 is 2 squared. So I into 2 the whole square, that is 2i the whole square. Therefore m squared is equal to 2i the whole square. So m is equal to plus or minus root of 2i the whole square, that is 2i. So m is equal to plus 2i and minus 2i. So these three are the roots, plus 1, plus 2i, minus 2i. When we combine these two, 0, we can write in this way, 0 plus or minus 2i, and this is 1. For 1, how to write CF? The first constant into e power x. This is for 1. And if you have a root of the form alpha plus or minus I beta, how to write the complementary function? E power alpha x into constant into cos beta x plus the next constant into sin beta x, right? So C1 I have started, no? Alpha, here alpha is 0 and beta is 2. So e power 0x, C1 I have started, so I can take this as C2. Cos beta is 2, cos 2x plus C3 sin 2x. So which is equal to C1 e power x, anything power 0 it is 1, plus C2 cos 2x plus C3 sin 2x. Is it clear? Now pi 1 by d cube minus d squared plus 4d minus 4. So replacing d by 1, the coefficient of x is 1, no? So 1 cube minus 1 squared plus 4 minus 4. These two are getting cancelled and these two. So 1 by 0 into e power x. When we get 0 in the denominator, what we have to do? We have to differentiate this taking x as a product. 1 by, when we differentiate that, it is 3d squared minus 2d plus 4 minus 0 into e power x. Now we have to replace x, d by 1. So 3 into 1 squared, that is 1, minus 2 into 1, that is 2, plus 4, which is equal to x by 5 e power x. So pi is x by 5 e power x. How to write the general solution? Y is equal to CF plus pi. Is it clear? Thank you.